Okay, we have mineral properties, or particularly we have the physical properties of minerals. So minerals differ from each other in chemical composition and architecture. And these structures produce distinctive physical properties that enable minerals to be identified. So we use these properties for identifying or in identifying the minerals. So minerals are solids formed primarily by inorganic processes. Each mineral has an orderly arrangement of atoms or crystalline structure and a particular chemical composition, which provides it a singular set of physical properties. So minerals can be identified by the following properties. So it can be identified by their luster, hardness, color and streak, crystal form or habit, cleavage, fracture, specific gravity, and special properties which I'm going to mention later as we go through our discussion. So the first before we delve deeper into each of these properties, okay, let's have an overview first. Okay, by looking at a particular chemical composition or a particular substance, such as the table salt. So we know that the chemical composition of table salt, which belongs to the group halite, is sodium chloride. So the luster, if you're going to observe, it is non-metallic. It is vitreous or glassy in appearance, which can be transparent to translucent. Hardness, it is soft. It falls between 2 to 2.5 of the Mohs scale of hardness. And then color is white. Streak is white. So we will differentiate later what do we mean by these properties here. Like for example, streak. And then crystal form or habit is cubic. So obviously you can see it here. It is in cube in appearance. Then the cleavage, it's perfect cubic. Specific gravity of 2.2, which is considerably light. And other properties that are unique for this uh, substance is has a salty taste. It's very soluble and it produces reddish spark in flame if you're going to have a flames test. So let's go first with luster. Okay, so it is the quality and intensity of reflected light exhibited by the mineral. So a mineral can either be metallic or non-metallic. Metallic being generally opaque and exhibit a resplendent shine similar to a polished metal. So it can be in metallic, it can be shiny, or it can be in non-metallic, it can be dull or earthy. So generally, the first thing you notice when identifying an unknown sample is its metallic luster. Okay, for example, like pyrite minerals or pyrite crystals. So non-metallic, it can be vitreous or glassy, like the salt, adamantine or brilliant or diamond-like, resinous. It can be silky, pearly, dull, or earthy, and greasy or oily in appearance. So here I have examples or images of minerals that belongs to metallic luster, or it exhibits a metallic luster. So we have pyrite. So you will see it's a bit shiny. Galena also, so it exhibits a metallic luster, and hematite. For non-metallic, it can be olivine, potassium, feldspar, and dolomite. Okay, dolomite being one of the components or the one in our Manila Bay, the sand. It is made of dolomite. Okay, so other for non-metallic, we have uh, adamantine. It's glassy in nature, resinous. It's like a resin. Vitreous, again, glassy. Pearly, greasy, it can be dull, okay, or opaque. Earthy, it can be chalky in appearance, and then silky, okay, like a texture or appearance of silk. So we have next hardness. It is a measure of the resistance of a mineral, not specifically surface, to abrasion. So we can see that hardness is actually a measure of the resistance of a mineral to abrasion or by using scratch test. So geologists use a standard hardness scale called Mohs scale to test the hardness. So it consists of 10 minerals arranged in order from 10 being the hardest to 1 being the softest. So Mohs hardness scale was designed by a German geologist or mineralogist Friedrich Mohs in 1812. That's why it's called Mohs scale of hardness. So the test compares the resistance of a mineral relative to the 10 reference minerals with known hardness. So it is simply determining the hardness of a mineral by scratching them with common objects of known hardness. Example, copper coin. So having a Mohs hardness of falling in the hardness scale of 3 to 3.5. So here's an example of the Mohs hardness scale. Okay, we have the 10 minerals mentioned. So 1 being talc, the softest, 2 gypsum, then 3 calcite, 4 fluorite, then next apatite, feldspar, quartz, topaz, corundum, and diamond being the hardest. So if you're going to see, uh, gypsum can scratch talc, but it can never scratch calcite because gypsum is harder than talc but softer compared to calcite. And diamond being the hardest, it can scratch all of the minerals under it. So if you're going to look at this one, we have fingernail. So the fingernail falls, wait, okay, fingernail here. Okay, so fingernail having 2.5. So fingernail can scratch gypsum and talc, but it can never scratch calcite. And calcite can scratch fingernail, gypsum, and talc. Okay, but never on the minerals above it. So we can have also steel file having 6.5. So it can scratch glass here and all the remaining minerals under the steel file, which falls 6 which has 6.5 hardness in the hardness scale. So this doesn't mean that diamond are 10 times harder than talc. Okay, so this is only a qualitative measure, not a quantitative measure. So it only measures the hardness or the how hard based on the scratch test, or if a particular mineral is harder or softer than the mineral or the other mineral that it is being compared to. So that's for the Mohs hardness scale. So what are the pros and cons in using Mohs hardness scale? Okay, so the advantage of using it is it's easy to do the test. Of course, all you need to do is just to have the different common objects, okay, and having the hardness in mind so you can identify whether a particular mineral or a particular substance can be scratched or be scratched by a particular mineral. So it can be done anywhere, anytime, as long as the place is not dark. Of course, if it's dark, you cannot see whether it has scratched or it has been scratched by a particular mineral. And then next, Mohs scale is highly relevant for field geologists to roughly identify minerals using scratch kits. So for immediate feedback about the hardness, you can use Mohs hardness scale. It can be done without or few kits, so it's quite handy. However, for the disadvantages, the scale is qualitative and not quantitative in terms of measurement. So you cannot expect to get an uh, exact measurement of a particular hardness of a mineral. It cannot be used to test accurate hardness of industrial materials. As I've said, it's only for qualitative measurement. So it's not really that exact. Okay, next, moving to the next physical property is color. So color may be a unique identifying property of certain minerals. Okay, example, the malachite, it has a green or green in color. So this one. And then we have also the azurite. Okay, azurite is blue in color, as you can see on this picture here. So of course, this is the most obvious feature of a mineral, but often an unreliable or least useful property in identifying minerals. So why is it the least, it's the least useful, or it is the most, actually it's an unreliable diagnostic property, or diagnostic, a diagnostic property in identifying minerals. It's because many minerals are found in several colors. So this is maybe attributed to the impurities added to the minerals, and some may have extra chemicals in them that give them an unexpected color. So example of this is, okay, we have here in our slide, so we have gold. Of course, it's yellowish, or it has this color. And then pyrite, okay, having a more, it has it's more in luster, it's more shiny. That's why it's also considered as fool's gold. So if you're not really into mining, so you will be fooled fooled by pyrite, and you can consider this as gold. So other examples are, okay, we have this mineral quartz. So due to impurities, quartz may have variety of colors, including, okay, pink. We can also have purple. So this is an amethyst. Okay, it can also be milky white, or even black, or even clear or glassy in appearance, or this color here, brownish, yellowish. Okay, so all of these are actually quartz, but due to the impurities present in the mineral, it can change in its color. So color, we can see here that color is not really a good or a reliable diagnostic property. Okay, we have also here, we have pure quartz belonging to silicate, has this color here. It's clear, or it's vitreous, but it can also appear in different colors.